So now let's talk about some properties of the gradient. So let's suppose that our function f is differentiable at the point x comma y. And so here are the following properties. So the first one says if the gradient at your point is 0, the 0 vector, then your directional derivative is 0 for all directions u. Well, this makes sense because remember that directional derivative is defined in terms of the dot product of your gradient. So if your gradient is the 0 vector, then your directional derivative will also be 0. The second property says the direction of maximum increase of f is given by the gradient of f of xy and the maximum value of your directional derivative is the magnitude of your gradient. And then property number 3 talks about the minimum now. So the direction of minimum increase of f is given by negative the gradient of f and the minimum value of our directional derivative is negative the magnitude of delta of your gradient. So just to kind of recap those last two, the direction of maximum increase is given by your gradient. And if you want to know the maximum value of your directional derivative, it's the magnitude of the gradient. And then minimum, the direction of minimum increase is given by negative the gradient, the opposite of the gradient. And the minimum value of your directional derivative is negative times the magnitude of the gradient. So let's put these properties to use and let's look at an example now. So I'm going to say that the temperature in degrees Celsius on the surface of a metal plate is given by the equation T of xy, which is 20 minus 4x squared minus y squared, where x and y are measured in centimeters. What, or I'll say in what direction from the point 2, -3 does the temperature increase most rapidly? what is the rate of increase. So here you're talking about temperature increasing most rapidly, so you want the maximum increase. So we need to look to our gradient. That's what our properties tell us, the gradient of our function. So take the derivative with respect to x, right? It's tx I plus ty j. Take the derivative with respect to x, you'll get negative 8x. Take the derivative with respect to y, you'll get negative 2y. So then, according to property 2, the direction of maximum increase is given by, plug your point into your gradient, to negative 3, you'll get negative 16i plus 6j. So there's the direction of maximum increase. I was also asked for the rate of that maximum increase. So the rate of increase is, I just take the magnitude of this vector here. So you square 16 and 6 squared. So you're going to get the square root of 292. And this is degrees per centimeter. So this is my maximum rate of change at that point.